we are going to discuss the method of solving of simultaneous linear equations. That's the method of elimination or substitution. In the method of elimination, just try to get the coefficient of any of the two variables and try to add or subtract the two equations for solving. Now let us try to solve by elimination. 7x plus 3y is equal to 16, 2x plus 9y is equal to 29. Now multiply the first equation by 3. 21x plus 9y equal to 48. 2x plus 9y is equal to 29. Now subtracting the two equations, got 19x as 19. That's x equal to 1. Now substitute the value of x in first equation. We got 7 plus 3y is equal to 16. That's 3y equal to 9. And y is equal to 9 by 3 as 3. Hence x equal to 1 and y is equal to 3 are solutions of the equations. Now let us solve by the method of substitution. Now rearranging the first equation, we got y as 3x minus 7. Now substitute the value of y in equation number 2. We got 10x plus 3 times 3x minus 7 equal to minus 2. That is 10x plus 9x minus 21 equal to minus 2. 19x equal to 19. That's we got the value of x as 1. Now substitute the value of x in equation number 3. That's y is equal to 3 minus 7. That's minus 4. Thus x equal to 1 and y is equal to minus 4 are the solutions of the equations. Now solving simultaneous quadratic equations. For example, x plus 2y equal to 3, x square plus 3xy equal to 10. Now try to arrange the first equation in a convenient way. That is x equal to 3 minus 2y. Now substitute the value of x in equation number 2 and try to solve for y. Put the value of y as minus 1 by 2 or y equal to minus 1. When y equal to minus 1 by 2, substituting in equation number 3, we got the value of x as 4. Again, when y equal to minus 1, value of x is 5. Let us try to solve. X plus y is equal to 9. X square minus 3xy plus 2y square is equal to 0. Now rearranging first equation. Y is equal to 9 minus x. Now substitute the value of y in equation number 2. X square minus 3x times 9 minus x plus 2 times 9 minus 6 the whole square equal to 0. That is x square minus 27x plus 3x square plus 2 times. Expanding 9 minus x the whole square. 81 minus 18x plus x square is equal to 0. That is x square minus 27x plus 3x square plus 162 minus 36x plus 2x square is equal to 0. Now rearranging 6x square minus 63x plus 162 equal to 0. Now by using quadratic formula, we got the value of x as 400 by 2, 6. Now by taking x as 400 by 2, we got the value of y as 400 by 2 from equation number 3. Now when x equal to 6, equation number 3 implies y is equal to 3. Next, solving of simultaneous equations by using graphs. Solutions of a pair of simultaneous equations represent the points of intersection of their graphs. Here the graph of linear equation and the graph of quadratic equation intersect twice. Hence the simultaneous equation have two real solutions. Here the two graphs never intersect. Therefore, these simultaneous equations have no real solutions. Now let us try to draw the graph of given pair of linear equations and try to find the point of intersection. Here are the steps for sketching your graphs. First of all, try to find out the corresponding coordinates of each graph. Now plot the x and y axis. Now mark the coordinates corresponding to y is equal to 3x plus 2. Then mark the coordinates corresponding to 3x plus 5 plus 1 equal to 0. Finally, mark the point of intersection of two graphs. Now join the graph by using straight line. Now mark 0, minus 1, minus 1, 2, 1, minus 4, now join the graph by using straight line. Now mark this graph as 3x plus 5 plus 1 equal to 0. Now try to find out the point of intersection. Hence we got the solution of two equations as x equal to minus 0.5 and y is equal to 0.5. Now let us try to sketch the graphs of 2y is equal to x plus 11 and y is equal to x square minus 3x minus 5 on the same axis and try to find out the points of intersection. First of all, try to find out the table values corresponding to y is equal to x plus 11 by 2. Now consider the quadratic equation y is equal to x square minus 3x minus 4. Now the crossing of y-axis is given by 0 minus 5. Now by solving the equation to x square minus 3x minus 5 is equal to 0, we got the crossing of x-axis as minus 1, 0, 5 by 2, 0. Now for finding the turning points, just rewrite the function as 2x square minus 3x minus 5 equal to 2 times 6 minus 3 by 4 the whole square minus 49 by 8. Now mark the turning points as 3 by 4 minus 49 by 8. Here the steps for sketching of two graphs. First of all, try to locate the corresponding points of 2y is equal to x plus 11. Now join the points by straight line. Next, sketch the parabola. Now the points of intersection of two graphs are given by minus 1.54 and 3.59. Now let us sketch the graph. First mark the point 0, 5.5, then minus 1, 4.5, now join the points by straight line. Now let us sketch the parabola. Mark the crossing of y-axis as 0, minus 5. Now the crossing of x-axis as minus 1, 0, 2.50. Now the turning point 3 by 4, 49 by 8. Sorry, 3 by 4 minus 49 by 8. Now sketch the parabola by freehand. Now mark the point of intersection. That is one point is 1.54. Next one 3.59. Now these are the solutions of the two equations. Now let us discuss the solutions of linear inequalities. The solution of an inequality is the set of all real number sets that make the inequality true. Now try to find the set of values of x for which 3x plus 2x times x minus 3 less than or equal to 2 times 5 plus 6 square. Now expanding bracket 3x plus 2x square minus 6x less than or equal to 10 plus 2x square. Now rearranging and simplifying. Minus 3x less than or equal to 10 or x greater than or equal to minus 10 by 3. Now let us try to mark the inequality on the number line. Here this point represents minus 10 by 3. Now x greater than or equal to minus 10 by 3 means the portion on the right side of minus 10 by 3 represents the solution of the inequality. Now let us try to solve. 15 minus x less than 2 times 11 minus x and 5 times 3x minus 1 greater than 12x plus 19. Here first of all try to solve the two inequalities separately. Now consider the first inequality and expanding bracket. 15 minus x less than 22 minus 2x. Now rearranging, x plus 2x is than 22 minus 15, that is 6 less than 7. Now expanding bracket for second inequality. 15x minus 5 greater than 12x plus 19. Now rearranging, 15 minus 12x greater than 19 plus 5. That's 3x greater than 24. Now x greater than 8. Now let us try to represent the two inequalities on the number line. Now mark the point x equal to 7. Here the inequality x less than 7 represents this portion on the number line. Now the inequality x greater than 8 represents this portion. Here there is no common portion for the two inequalities. Therefore the whole statement has no solution. Now let us discuss the solving of quadratic inequalities graphically. Now let us find the set of values of x for which 3 minus 5x minus 2x square less than 0. Here in the graph, this portion represents 3 minus 5x minus 2x square less than 0. That's the x value corresponding to this portion of graph is this one and this one. The left side x value corresponds to the inequality x less than minus 3 and the right side portion corresponds to the inequality x greater than 1 by 2. Hence the required set of values is x less than minus 3 or x greater than 1 by 2. Now let us try to find out the set of values of x for which x square minus 8x plus 3 less than or equal to 0 graphically. Here the graph crosses the y-axis at 0, 3. Now the crossing of x-axis is given by 1 by 2, 0, 3 by 2, 0. Now the turning points are 1 minus 1. Here the inequality for x square minus 8x plus 3 less than or equal to 0 is represented by this portion of the graph. And the corresponding x values is given by this portion. Now the inequality corresponding to this portion of x-axis is 1 by 2 less than or equal to x less than or equal to 3 by 2. And this gives the solution of the inequality for x square minus 8x plus 3 less than or equal to 0. Here we discuss the inequalities of the form f of x less than g of x or f of x greater than g of x and their graphical solutions. Now let us consider the equation L1 as y is equal to 12 plus 4x and L2 as y is equal to x square. And we have to write down the solution to the inequality 12 plus 4x greater than x square. Now after solving, we got the point P1 as 636 and the point P2 as minus 24. Here 12 plus 4x greater than x square when the graph of L1 is above the graph of L2. Now let us locate the corresponding x values of this portion. That's 6 equal to 6 and x equal to minus 2. Now the range of values of x for which 12 plus 4x greater than x square is given by this portion on the x-axis. It's represented by minus 2 less than x less than 6. Now consider the pair of equations f of x equal to x square plus 5, g of x equal to 5 minus 2x and write down the solutions to inequality f of x less than or equal to g of x. Now for the function f of x equal to x square plus 5, the crossing of y-axis is given by 0, 5. Now by taking x square plus 5 as 0, we got s square is equal to minus 5. That is, no real solutions exist. Hence the graph never crosses the x-axis. Now by rearranging f of x as x minus 0 the whole square plus 5, we got the turning point as 0, 5. Now after plotting the two graphs, we got the point of intersection as 0, 5 and minus 2, 9. Now f of x less than or equal to g of x implies the graph of f of x is below the graph of g of x. Now the corresponding x coordinates are given by that is x equal to minus 2 and x equal to 0. Now the corresponding range values of x is represented by this portion on the x-axis. Thus the solution corresponding to f of x less than or equal to g of x is minus 2 less than or equal to x less than or equal to 0. Now let us discuss regions satisfying the inequalities of the form y less than f of x or y greater than f of x. First of all, skip the graph of y is equal to f of x. The yellow shaded region represents the inequality y greater than f of x and the unshaded region represents the inequality y less than f of x. For example, on the graph paper, shade the region that satisfies the inequalities to y plus x less than 14 and y greater than or equal to x square minus 3x minus 4. First of all, sketch the graph of 2y plus x equal to 14. Here, dotted line represents the graph of 2y plus x equal to 14. Now consider a point 0, 0 in the region below the graph 2y plus x equal to 14. Now the inequality 1 becomes 0 less than 14. Therefore, the region below the line 2y plus x equal to 14 represents the inequality 2y plus x less than 14. Now consider a point 0, 0 in the region inside of the parabola. Now inequality 2 becomes 0 greater than minus 4. Therefore, the inequality y greater than or equal to x square minus 3x minus 4 represents the region inside the parabola. Now the shaded portion in the graph represents the region satisfying the two inequalities. Now on a coordinate grid, let us shade the region that satisfies the inequalities x greater than or equal to minus 1, y plus x less than 4, 2x plus y less than or equal to 5, and y greater than minus 2. Now sketch the graph of x equal to minus 1. Now sketch y is equal to minus 2. Now let us draw the graph of y plus x equal to 4. Now let us get 2x plus y equal to 5. Now let us get 2x plus y equal to 5. Next, on a coordinate grid, shade the region that satisfies the inequalities y less than 3 minus 6 into 2 plus x and y plus x greater than or equal to 3. Now after sketching, let us try to shade the region satisfying the two inequalities. Now consider the inequality y plus x greater than or equal to 3. Now let us consider a point 2, 2. Then the inequality becomes 4 greater than 3. Therefore, the region contains the point 2, 2 represents the inequality y plus x greater than or equal to 3. Now for the inequality y less than 3 minus x into 2 plus x, the point 2, 2 implies 2 less than 4. Therefore, the region containing the point 2, 2 represents the inequality y less than 3 minus x into 2 plus x. Now let us mark the required region.